Support comes from Mosby Building Arts, designing basements where kids can play and relax. Information at callmosby.com.
This is St. Louis on the Air from St. Louis Public Radio.
I'm Kate Grumke in for Elaine Cha. It's time to talk about breasts. Breasts and blood and fat and vaginas and wombs. Our next guest asks us to each look at female bodies and think hard about how they shape what it means to be human. Joining me now is Cat Bohannon. She's a researcher and author with a PhD from Columbia University in narrative and cognition. She studied how storytelling works in the human brain, and she's the author of the 2023 book, Eve, How the Female Body Drove 200 Million Years of Human Evolution. That book came out in paperback last month, and Cat Bohannon is in town for an author event tonight at 7 at St. Louis County Library's Clark Family Branch. Cat Bohannon, welcome to St. Louis on the Air.
Hello, thanks for having me. It's Vag o'clock, y'all. Let's do it.
In Eve, you argue that human evolution is best understood through the lens of the female body. Why do you think this perspective has been overlooked for so long?
Well, the short answer to that is usually sexism. It exists. Hey, it's a thing in every field. Big news, right? But in this case, it's actually that in biology and in the biomedical sciences, we're in the midst of this really big shift. We're starting to think about bodies as things that are actually a little bit more diverse than we used to be. For example, we don't think of ourselves as a Mr. Potato Head anymore, right? That it's not just a mono model, just a male model, and if you're female, a few small things change. Actually, sex differences tend to influence us at every tier of our body, and not usually where you'd expect.
And how has science historically ignored the female body?
Oh, just entirely. That's the shortest answer. Just completely. Hi, it's what you thought. So what really happened is that female mammals have this thing called estrus. You and I might call it the menstrual cycle, our periods. And what that does is this cascade of hormones goes up and down over a certain period in every animal that has it. But you might not know that nearly every tissue in your body has sex hormone receptors, and we only sort of know how they work because for a long time, well, the way to control for this messy problem was to just not study females at all. Then you don't have to worry about what it's doing. Unfortunately, that meant for a very long time at every tier of that research pipeline, including all the way to the drugs you use now, they may not have been studied on females at all, which left us for a long time as guinea pigs.
And that was described as clean research, right?
Absolutely. This is the idea that if you're a scientist, you want to build this elegant experiment. You want to understand the data in front of you. You want to control for your confounds, right? And it turned out simply being female was a big, fat, messy confound.
Your book takes a multidisciplinary approach and includes biology, anthropology, neuroscience, instead of just looking at biology. How did that approach change your findings?
Well, my own PhD at Columbia was interdisciplinary, and so I already had the kind of funny habit of regularly being humbled. What you have to do when you work outside of your discipline, and people who are listening might have to do this sometimes themselves, you have to walk across the hall into the office of a very smart person who knows a lot more about a subject than you do, and you sit down and you say, "Hi, I've read a bunch of stuff and here are my questions. Now please tell me all the ways that I'm getting something wrong so that we can get to those answers that might be right." But the thing is with big questions like these, especially when you're trying to right a wrong, you have to kind of get everybody on board. You have to actually reach out beyond your comfort zone.
And the book has an interesting structure, focusing on a different evolutionary precursor in each chapter, which you call our Eves. Mm-hmm. Why did you decide to structure it that way?
Oh, well, actually, besides just that it makes for a better story because, evolution progresses over time. So that helps. And you meet some lovely little weasel-like creatures that lived with dinosaurs, which are why we lactate and later why we have periods. So who we're looking for to blame, really, is what we find there. But the main reason I do it is because there's a reason we study rats. And it's not just that we hate rats. I mean, look, I did, when I was a grad student at Columbia, see a rat crawl out of my toaster. And I did throw away that toaster, which is obviously the only right answer. What are you going to say to your roommates, right? But the thing is that we study rats because there's this assumption of what in sciences we call the conservation of traits. The reason you can build a rat model in a lab of something like, I don't know, diabetes, the reason we can test diabetes drugs on rats first is because it wasn't that long ago that we were really rat-like, right? Then in evolutionary time, 200 million years is kind of a nothing burger. So if you want to look for analogs to what might be there in our bodies and maybe look for new treatments, other mammals is a good place to start.
And do you have a favorite Eve in the book?
Oh, I do kind of love Morgie. She is about 200 million years ago. She's a little weasel-like chick, lives under the actual feet of dinosaurs, and she's why we still lactate, although she, much like the duck-billed platypus today, still laid eggs, which many of the rest of us in mammal land decided not to do, which I maintain is a bad idea. I would much rather have laid some eggs than made my babies the way I did.
And I think Morgie was my favorite too, but what was lactation like then? It wasn't like it is now.
Well, there were no nipples, so there's a thing we can say on radio. There were no nipples among those creatures. There were just these little furry patches. And the duck-billed platypus still does this today, and that's part of how we assume that was true. They'll just, lick their little tongues out between their weird beaks and just lick milk off the mama's furry belly, and that's how they get milk. Nipples are a much later add-on, though once you have them, they are very cool.
And very precise for getting the milk out, right?
Yeah, so you control for slop in the system, right? So if you can just kind of picture, yes, we are asking you on public radio to picture, you're wrapping your nipple, if you're a newborn, you're wrapping your mouth around the nipple of the mother when you're trying to breastfeed. Okay, if you're any good at it, many kids are not. If you're any good at it, you're forming a kind of docking seal, right? And you're forming a vacuum in your mouth, and you suck in your cheeks to kind of draw that milk out and stimulate the breast to let more down. Well, that's fine, but the funny thing about the physics of it is that as you swallow and as you're moving that sucking motion around in your mouth, you're actually creating a tide. A lot like you might see on a beach, right? So over the top, you get that wave of milk, and that's what you swallow. But then with any tide, you get an undertow. And so your saliva as a newborn is actually being sucked back up into your mother's breast through the nipple, where it's then read like some weird ancient code by this army of immunoagents and sensors that weirdly tailor the milk to suit. If you're sick, your mom's milk changes. And that's just true in rat as it seems to be in human.
This is the fact that I keep repeating to everyone I'm talking to about this book.
Yeah.
So again and again in the book, we see that human evolution was not linear. So how did your understanding of evolution change as you researched and wrote Eve?
Well, some things were confirmed. Part of what was confirmed was a deep knowledge that probably you and all of your listeners have, that our bodies are weird, and the more you notice how weird they are, the weirder they actually seem to get. Interestingly, in the sciences, that's also true. So in deep evolution, there's just so much accident that got us to where we are today, and so many things are still unsurprisingly pretty janky in how our bodies work, but some of them are also quite beautiful.
And you mentioned that Morgie was still laying eggs, but at some point in our evolutionary journey, our distant ancestors stopped doing that.
Yep.
And instead started essentially hatching eggs in our bodies. You wrote that you're not sure it's possible to sufficiently explain how insane this is.
Oh, yeah.
I would like you to try.
Oh, my goodness. Okay, so if you lay an egg externally, then all your body really has to do besides make an egg is make a yolk sac, right? Like maybe you'll also do things like some birds do, like keep them warm, sit on them, stuff like that. Or maybe you're like a fish and you just let fly in the ocean. You're like, I'm out. Actually, some fish are careful brooders. Anyway, you can look into that yourselves. But the point is that the cost to your body and the impact on your immune system, of course, is actually pretty high once you start having anything like a placenta. Because now, once you have a placenta, and that's where your umbilical cord attaches, that's where you attach to the uterus, that means that the way we make babies impacts our immune system, our liver, our lungs, our hearts. There is literally no part of your body that is unpregnant if you're pregnant, right? And that, of course, can mean a lot more things can go wrong when they do.
And throughout the book, you describe the relationship between a fetus and its mother as a kind of war.
Yeah.
Why do you describe it that way?
Look, I love my kids. They're beautiful. They're semi-feral. Their ages 4 and 6. It's a good age, right? But I will say that I and many other pregnant people did often feel like when we were knocked up, like, why is it this hard though? Right? And it turns out it's that hard because basically there's such a thing as maternal fetal competition. What that means is that the maternal body and that baby's body are competing for resources. There's only one pool of resources, y'all, so they're drawing from either side. And actually, a lot of those birth complications can be tied to kind of an imbalance between what the mother's body needs to survive and thrive, and likewise what the fetal body is constantly trying to hoover out and distract her and kind of pull in, right? So it's more like pregnancy is a 9-month trench warfare. It's a détente that hopefully ends without too much damage to either.
And those are the downsides. What are the kind of upsides of growing that egg inside of our whole body shell?
We don't entirely know. I'll be 100% honest with you. For a long time, we thought at the very least having been pregnant and given birth at least once reduced your risk of many kinds of cancers, that even breastfeeding would reduce your risk of breast cancer. Annoyingly, it turned out that actually just being pregnant ups your risk of breast cancer for at least 5 years, and then it peaks and then it slides down and lasts for at least 20. So that was disappointing for me because that was part of what I anticipated my payoff would be. But no, actually, we're not entirely sure what the perks are, although we can say reliably, the female immune system does seem to be more robust than the male, and that's true from birth, and it might be tied to that.
We need to take a quick break. We'll be back shortly to continue this conversation. I'm talking with Cat Bohannon, author of Eve, How the Female Body Drove 200 Million Years of Human Evolution. This is St. Louis on the Air on St. Louis Public Radio. Welcome back. We're here with Cat Bohannon, author of Eve, How the Female Body Drove 200 Million Years of Human Evolution. Cat will be at St. Louis County Library's Clark Family Branch for an author event this evening at 7. We were just talking about the unique horrors of growing a human baby inside of your body. In the book, you argue that the most important human invention was gynecology, and midwifery made us human. Why do you think that?
Oh, yeah, I know. It's a bold claim, but I think I support it pretty well. The Atlantic thought I did all right as well. So, okay, here's your basic premise, right? So you can ask yourself all kinds of things about what was our most important tool, what was our most important invention, and you'll come up with all kinds of great candidates. Fire was great. Now we don't have to die all the time of horrible infectious diseases every time we eat food. We love that. We love fire, right? We love penicillin. Hope it keeps working. We love many, many things. We love the wheel. We love all sorts of stuff. But the thing is that if you're looking down to like what's basal, what's common throughout even pre-human, hominin evolution, we know we're tool users, right? But the thing is about a tool, it's not about the tool itself. The thing that any paleoanthropologist will tell you is what you really care about is a weird triangle, right? You care about the user, that user in its environment, and its goal. And how is it going to use something to overcome a bodily limitation to achieve that goal, right? Okay, well, that means that the main thing you're looking for when you say what was our most important invention, our innovation in this space, wasn't necessarily the object. It was a behavioral thing. What did we do? And importantly, what was our biggest bodily limitation that we had to overcome and then build tools and behaviors around it? All right. Well, our biggest bodily limitation actually was not how fast we could run or how sharp our teeth were or any of that. Our biggest limitation is that as a species, we kind of suck at making babies. We do. Our pregnancies and our births and postpartum recoveries are longer and harder and more prone to dangerous and sometimes crippling and sometimes even deadly complications for mother and child than they are for almost any other primate like us. Except for a squirrel monkey. We feel real bad for her. But otherwise, right, actually, it's kind of hard for us even among mammals, right? And so it's not that you can't have a healthy pregnancy. Of course you can. It's not that pregnancy is a disease. No, no, no. But it is hard. Birthing bodies do hard things. And actually, they've always done hard things. In fact, it's so hard that our species shouldn't have existed. We should be a curiosity in somebody else's zoo, okay? We should be on the endangered list. But we're not. And the reason we're not, in small part, is that large part, is that we invented midwifery. We are the only species that regularly helps one another give birth. Nobody else is doing that out there, man. You can look wherever you want on the Discovery Channel. That's us. And we did it because for about 3.2 million years, the way we make babies is just by nature hard to do.
And why is that? What is unique about the human body compared to some of our relatives in the animal kingdom?
So some of it is what's called the obstetric dilemma. So when we started walking upright, those bones, if you put your own hands on your hip bones, you can feel that little bit of it, right? Those bones, that iliac crest, those used to be way out wide. And then when we stood up effectively in evolutionary time, well, that restructured how those bones fit together in order to anchor our muscles. And that made the hole in which our babies come out smaller and a little funny shaped. Meanwhile, our heads kept getting bigger and our shoulders holding up our stupidly big heads. So nowadays what we have is this situation where we're trying to squeeze a watermelon-sized thing out of a lemon-sized hole. So that's awesome. But also it's true that our brains are really metabolically expensive. It's like you're running a sports car in your head, which means that what we have, this one theory, is that we have this really invasive placenta that hoovers out a lot of material to build that big brain when you're carrying a fetus, right? So then a more deeply invasive placenta, well, that's harder to detach when you give birth. A deeply invasive placenta, well, that might start upping your blood pressure. That's a thing. And in fact, one of the biggest drivers of maternal mortality in the U.S. right now is cardiac conditions. It's hard on the heart to be pregnant. Go to your prenatal appointments. Again, if you're pregnant, don't be scared. You'll be fine. Just take that wonderful health care you've got and make use of it. But when you look back at our ancestry, it's like, well, okay then. That's actually a big story. The story of humanity is very much a story of moms.
And of moms helping each other get through that difficult thing.
Yes.
And I was fascinated by the sections on how human brains develop, especially compared to our ape cousins. What do humans do differently that helps us build these organic supercomputers?
Yes, exactly right. So your brain is effectively a supercomputer that runs on fat and sugar. It's amazing it works at all, and it is as buggy as you'd imagine. If you've upgraded your phone, then you can understand why the human brain is not as great now because it's just gotten a recently beta-tested kind of upgrade. Okay, so the thing that we do that's really cool and interesting is we extended our childhood. Basically, when we're born, our brains are going to keep growing, keep developing, keep changing, actually all the way to our mid-20s, even when we end out a lot of what we call puberty, it's still going, y'all, right into our mid-20s. And that's different. That does seem to be very different than what a chimp or a bonobo will do when they're pretty much ready to go as teenagers.
And there's a difference even in communication for chimps versus humans, right? Mm-hmm. Can you talk about how our babies communicate with us versus chimps of a similar age?
Yeah, so this is one of these really interesting things in cognitive science. Our offspring, when they come out, our human babies, they are so adorably useless. Like they can't even hold up their heads for a while, and then they're not really good at moving around for a while. But a newborn chimpanzee or bonobo, our closest cousins, they actually come out pretty ready to grab onto stuff and move around and communicate. So one of the theories is that because we're so helpless, we developed really smart communication patterns with our caretakers. We can point to a thing, anticipating that you'll then look there and know what we want before we can move. You can see a baby pointing to stuff. That's a big cognitive milestone. Chimps actually kind of don't want to just point the one time. If they point, they want to point like 20 times and then make hoot pants and maybe jump over the table at you and hold you by the hand to show you the sweet fruit that they want. Like they don't have that same deep anticipation of your thoughts. And that seems to be a really human-like thing.
And you go all the way to menopause in the book. So we're not just talking about birth and raising babies. Why is menopause such a huge mystery in modern biology?
Well, one of the reasons it's a mystery is that it's basically us and 4 species of toothed whale that have it. So that's not a well-studied trait, okay? That's like, and it's hard to study whales because they live in the ocean and we can't breathe water. Many reasons. But we have learned that it's basically us and a few different types of whales, especially transient orcapods. Those are your killer whales. It's not Free Willy. It's more like Free Thelma. They're matriarchal and menopausal. And the menopausal females are leading that pod. What's weird and interesting about us and the killer whales is that most mammals kind of keep reproducing, males and females, right up until they kick the bucket. They don't keep living a full third of their potential lifespan after stopping ovulation. And that's what menopause is. It's not actually a story about your ovaries as much as it's a story about being not dead. Congratulations, ladies. If you made it, you're still not dead, and that means you're in menopause, right? But the cool thing about menopause, then, is that you understand that it's a question about how did we live longer, not a question about how did we shut down our ovaries, right? So in our deep ancestral past, what we did is the whole species, it looks like, the best as I can tell, started developing traits to let our bodies delay aging, let us live longer. We are doing a lot better at age 60 than a chimp, let me tell you what, right? And that's true for both males and females. Although what is interesting is that our ovaries may not have gotten the message. It's more like they're still running the old monkey plan, right? And so they're still anticipating that we are definitely going to be dead really soon if we passed 50. But we don't. Actually, all of us keep on living if we're lucky enough to have good health care and lifestyle.
And you write throughout the book about how all of this has affected human society. And you also kind of take down some of the theories that have been present before. Some, for example, think agriculture made cities possible, but you write that it could have also been female bodies. Why do you think that female bodies made cities possible?
Ancient demography. Wasn't this fun? So the funny thing about a lot of ancient modeling of how urbanization came to be. Where did cities come from? How did so many, and it's a convergent thing, many different cultural traditions will end up producing urbanization. It didn't just happen in the Middle East, y'all, actually, and then in the Americas that happened too, just at different points in time. But the thing about urbanization is that you have to make enough bodies to live in a city. Like literally very few of these models anticipate that female reproduction is directly affected by an environment, which is weird because, we're half of the people living in that city. And we're literally making those babies. So the thing that they don't always talk about is that breastfeeding is an ovulation suppressant. Now, please use other forms of birth control, y'all, and talk to your MD. All right, but so this is not a good method, but I will say it is an imperfect ovulation suppressant. It makes you not have your period for a while. It makes you not be fertile for a while. Right? But many ancient cultures had wet nurses. So you take your baby off your own boob, give it to somebody else's boob, and then there you are, right? Okay, that sounds fine, but that means you're going to become fertile sooner than you would otherwise had you kept breastfeeding. Meanwhile, the other person who is now nursing your baby is not necessarily perfectly not fertile. Right? Which means that the two of you are now having more babies more quickly than you would have had you not done this. And all of the ancient cultures that have been studied that had this practice, their populations exploded, man. They actually had urban overcrowding in ancient Babylon, and they had breastfeeding. In local tribes that didn't have this kind of wet nursing practice, well, they didn't have as many babies.
You write that sexism at its core is a massive set of rules that work to control reproduction. Since the Supreme Court overturned Roe v. Wade, Missouri has seen shifting rules around abortion. We were one of the first states to ban almost all abortions after the decision, and we've since voted to enshrine the right to an abortion in the state constitution. Ooh. What do you think an evolutionary perspective can add to how we think about the modern fight over abortion?
Well, oh my goodness. I mean, thank you for putting that in your Constitution. It is a hell of a time, ladies, ain't it? Oh my. All right, look. Here's the thing. There is nothing in your genes that makes you want a hemline to be a certain length. There is nothing in your genes, in other words, that codes for specific rules around female bodies. In fact, all you can really say is that in every human culture that is well studied now or existed historically, every single culture has sex rules. What the rules are differ, how we feel about them differ, but we all feel strongly about them. And what so many of these rules do is they control access to female bodies. Where can she go? Whom can she socialize with? How much of that body can be seen, and by whom, and in what circumstance? And by the time you actually get to the rules around the actual sexing, so many rules and so culturally specific. But from a biologist's point of view, what that's doing is it's controlling male access to female bodies. It's controlling her fertility rate. How often is she going to have babies, and when and where, in a culturally specific condition, right? So if you assume that in our deep, deep past as human beings, it was dangerous and difficult to make babies, this would be another set of things that culturally, behaviorally, a culture could do to innovate around this problem and try to keep more females and offspring alive. So you should think of it then in that deep history. I don't mean the last history when white people did terrible things to black women. Please remember Anarcha. You can Google it, right? I'm talking about the deep history of gynecology. That's going to go hand in hand with a lot of these sex rules, right? They're all behaviors to help females survive and thrive. But nowadays, our gynecology is so much better at keeping us alive than having strict social rules around her sex life. So much better at that, right? So if anything, I say, if you look at deep time, if you think about it through that scientific lens, then you can say, well, now we're at a point where we can get our heads above water and make choices.
And I'm curious, when you do author events like you're doing tonight, what do you find audience members most want to know, or what do they ask the most about?
So they ask me so many things, and they tell me so many things about their bodies, and I hold space for that because being intimate with a stranger, even through words, is an honor. It's a privilege. They're telling you something they don't tell everybody. So my signing lines tend to be long, and that's fine. They most want to know things like, do I need to be terrified of every medicine I take as a person with ovaries? Is that just like, do I have to worry about my daughters? Is that a thing? And I can tell you that we're getting better. The rules are changing. We're finally catching up on filling that women's health equity gap, finding out how female bodies really work, but it is slow going. And just remember that diagnosis is something that you do together with your doctor. It's a collaborative thing. You figure it out together. It's not just a service you receive, you know? So when you think about it that way, then you can say, okay, we can fix this together.
In our final minute, what is the main thing you hope your readers take away from Eve?
Biology is always weirder than you think. But remember that you are already the best authority on what it's been like to live in your body. You are actually the world's expert on that. So books like these, conversations like these, they're here to give you tools to use to describe that experience you're already an authority on. They're here to give you good weapons in the fight, and we are in a fight right now. And they're here, more than anything else, to just enrich your understanding of this messy life you're living in this body that, frankly, is your only one you're going to get.
Cat, thanks for joining us today.
Absolutely. Thanks for having me.
Today's episode was produced by our executive producer, Alex Hoyer.
Audio engineering and podcast design by Aaron Dorr.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations. And leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thanks.
St. Louis Public Radio is a member-supported service of the University of Missouri St. Louis.
The Gateway brings you the day's news each weekday from around the St. Louis region and the state capitals in Jefferson City.
Our schools are accredited. We don't need this bill.
And Springfield.
How many more years must pass before lawmakers see time is of the essence?
I'm Abby Larico. Join me each weekday for The Gateway on the STLPR app or wherever you get podcasts.